For 7 decades of thousands of years, Mount Taftan kept up one convincing act, being dead. But fresh satellite data tells a different story. Its peak is climbing, as if something buried underneath is stretching out, twisting around, and popping its joints after the longest nap in recorded history. Researchers are not thrilled about this, so let's dig into whether you should be worried too. Normally, a volcano stirs when an earthquake rattles it loose, or when a storm messes with the groundwater trapped beneath it. Except when experts went looking, there was no major quake and no heavy rainfall anywhere near southeastern Iran, where Taftan sits, which leaves one explanation: gas or magma pressure is doing the pushing. Picture a sealed can of soda left in the sun. Long before it hisses, pressure is quietly stacking up inside, hunting for the weak spot. That's precisely why Taftan's rising summit is such a glaring warning sign. A pressure shift almost always points to fresh activity underground. And here's the part that makes it worse. Whatever is pushing from below sits only around 1,600 to 2,700 feet down. That's shallow, as volcanoes go. When the pressure source sits that close to the surface, it doesn't need lava to cause trouble. Steam or trapped gas alone can trigger sudden blasts. Volcanologists call this a Friedrich explosion. It happens when underground water heats up so quickly that it detonates like an overloaded pressure cooker. Movies love to show lava chasing people down city streets, but a steam-driven blast is a completely different animal. Quiet, sudden, and almost impossible to see coming. One moment it's calm, and the next, rock and scalding steam are punching into the sky with the force of a jet engine. That's the exact scenario keeping researchers up at night when it comes to Taftan. You don't need flowing lava to wreck a landscape. A Friedrich blast alone can hurl car-sized boulders and send ash columns thousands of feet skyward. And even if Iran is nowhere near you, Taftan's problem doesn't stay local. Volcanic gas rides the wind, and Taftan is known for pumping out sulfur-heavy emissions when it's stirring. Sulfur dioxide isn't just a foul smell. It damages air quality, irritates the lungs, and reacts in the atmosphere to form particles that can block sunlight and cool the climate. That means countries nowhere near the mountain could still feel the fallout. And if a Friedrich blast throws ash high enough, it could drift straight into busy flight corridors, an unwanted cloud of volcanic confetti. Even a fairly small eruption can cause outsized chaos. Remember that Icelandic volcano in 2010, the one with the name nobody could pronounce? It shut down air travel across the entire Atlantic. A modest ash cloud here could just as easily ground flights across the Middle East, South Asia, and further out. Volcanic gas doesn't care about borders. It drifts, mixes, and settles wherever the wind takes it. Okay, this all sounds unnerving, but surely with today's sensors, scientists would catch an eruption coming, right? Not exactly. Taftan sits in such a remote stretch of land that installing monitoring gear there is difficult, costly, and, until recently, nobody bothered. Because everyone assumed the volcano was finished for good. So right now, it's mostly satellites doing the heavy lifting, not instruments planted on the mountain itself. Satellites capture the wide view, but ground sensors are what fill in the fine detail, which is exactly why reclassifying Taftan from extinct to dormant mattered so much. Dormant volcanoes need constant watching. Once a volcano is stamped extinct, governments stop funding evacuation plans, hazard maps, or monitoring stations for it. Changing Taftan's status forced everyone, from local authorities to international scientists, to admit it's capable of causing real damage. That means planning for ashfall, gas leaks, sudden blasts, and the bigger, harder questions. Like, what if this waking up phase isn't temporary? What if it marks the start of an entirely new cycle of activity? Taftan could quiet back down, or it might be entering a stretch of renewed unrest. Volcanoes don't operate on a human sense of time. What feels short-term to us could stretch across days, or it could stretch across years, and that rising summit could signal something deeper than a surface hiccup. Actual magma shifting below. Between July 2023 and May 2024, the peak climbed roughly 3.5 inches. A rising mountain is Earth taking a long, slow inhale. And whenever the planet inhales that deeply, eventually it has to exhale. And in volcano terms, that exhale is never good news. Right now, Taftan is still breathing in. Nobody knows when, or if, it plans to breathe back out. And if you thought that was enough drama for one story, brace yourself, because some of the largest, most volatile supervolcanoes on the planet are also stirring. When one of these giants erupts, the entire globe feels it, even people living continents away. What terrifies scientists isn't only the eruption itself, but the speed of it. A super eruption could easily outpace our ability to stockpile supplies, evacuate cities, or manage the aftermath. That's the real nightmare. Not just the blast, but how little time we'd have to respond. If you've ever been near Naples, you've already met one of these giants up close. Roads split open, steam seeps from the ground, the harbor fills in with sediment, and clusters of small quakes rattle window panes like thunder from underground. All of that comes courtesy of Campi Flegrei, a colossal supervolcano caldera whose last eruption dates back to 1538. For a long time, researchers read all these signs as textbook indicators of rising magma. Then two studies, one published in 2023, another in 2025, flipped that understanding on its head. And oddly enough, they brought a little bit of relief mixed in with the danger. The 2023 research zeroed in on carbon dioxide, a gas that volcanoes release when magma becomes active. At Campi Flegrei, CO2 output spiked after 2005, climbing to somewhere between 4,000 and 5,000 tons per day, numbers that would normally scream magma on the move. But when scientists cross-checked other gases, like nitrogen and helium, the chemistry simply didn't line up with that theory. It turned out the extra carbon dioxide wasn't coming from rising magma at all. It was coming from scorching hot underground fluids cooking the surrounding rock and releasing gas on their own. Then the 2025 study went further. Lab simulations revealed that most of the shaking traces back to a sealed pocket of underground water and steam. When that natural cap traps enough pressure, it eventually fractures, releases a burst of steam, and triggers the quakes people feel on the surface. That theory also solves a mystery that had puzzled researchers for years: why the tremors typically start shallow and then migrate deeper. The exact opposite of what you'd expect if magma were rising. And after the strongest tremors, the ground tends to sink slightly afterward, almost like a balloon slowly losing air. None of this makes Campi Flegrei safe, though. Magma is still sitting down there, and steam-triggered blasts can still hurl rock, ash, and superheated gas without any advance warning from lava. What's actually shifted is how experts approach the risk. Simply observing and waiting isn't sufficient anymore. If humanity had only a year's notice before a super eruption, we would be in serious trouble. Stockpiling food, moving populations, keeping supply chains functioning. Almost none of it would go smoothly. That said, don't panic. Yet, genuine super eruptions are exceptionally rare. The most recent one struck roughly 26,500 years ago in New Zealand. On average, researchers estimate a super eruption happens once every 100,000 years or so, though Earth doesn't stick to a tidy calendar. Sometimes these events bunch closer together, and then the planet stays calm for long, uneventful stretches. Two enormous super eruptions rocked the planet within the last 100,000 years. Around 74,000 years back, Indonesia's Toba volcano detonated with such power that ash spread across all of Asia. Global temperatures dropped, and it may have pushed early humans right to the edge of extinction. Then, roughly 26,500 years ago, New Zealand's Taupo volcano let loose, burying vast stretches of land in ash and reshaping the terrain we still see today. There's always a possibility another super eruption strikes sooner than models predict. And that uncertainty is exactly what keeps scientists on edge. Now, let's turn to Kilauea, one of the most active volcanoes anywhere on Earth, which erupted again in March 2026 on Hawaii's Big Island. Towering lava fountains shot skyward, the main highway shut down, and the airport was blanketed by gritty clouds of ash. The sky glowed an eerie deep red. That's how dense the smoke got. The eruption forced parts of the island to close entirely. It was the second time this had happened this year alone. The activity broke out inside the Halemaumau crater at the volcano's summit, and conditions turned dangerous fast enough that visitors had to be evacuated from the area. The lava fountain itself blasted roughly 1,300 feet into the air, taller than the Eiffel Tower, and nearly as tall as the Empire State Building. Let's walk through how it played out. The eruption began on March 10, 2026, and ran for about 9 hours, wrapping up suddenly at 6:21 in the evening. It kicked off around 9:17 that morning, with lava erupting from the north vent first. The south vent followed shortly before 10 a.m. By early afternoon, both fountains had grown massive. The south vent reached roughly 1,150 feet, while the north vent climbed to about 1,000. Lava spread across roughly a third of the crater floor, glowing in brilliant orange and red. As the lava cools midair, it hardens into something called tephra, a rough blend of volcanic rock, ash, and tiny glass fragments. Tephra can scrape skin like sandpaper, sting your eyes, and make breathing painful. It's also capable of turning roadways into ice rink conditions for vehicles. Because of that, stretch of Highway 11 was shut down between mile markers 24 and 40. Back in January, an earlier eruption also rained tephra across the park and surrounding towns. A few unlucky visitors were struck and even cut. Park officials had to close the summit for the very first time since the current eruption cycle began on December 23, 2024. According to the National Weather Service, the eruption's plume climbed to 25,000 feet, nearly 5 miles straight up, higher than most commercial aircraft crews. Winds were blowing in from the south, pushing ash and gas northward from Halemaumau. Officials urged nearby residents to stay indoors or leave the area entirely if the fumes became too much to handle. This wasn't Kilauea's only outburst this year. An earlier eruption began on February 15th and lasted almost 10 hours, during which lava covered half of the crater floor. Scientists estimate roughly 15 million cubic yards of lava poured out during that event, enough to fill thousands of swimming pools or blanket hundreds of football fields. By 2 p.m. on March 10th, tephra was still falling, and park rangers were busy moving visitors away from the summit. Every trail and viewpoint near the crater was closed off. Researchers, the situation around the clock, tracking how high the fountains climbed, how quickly lava was flowing, which direction the ash cloud drifted, and where the debris was likely to land. Even though the lava largely stays contained within the crater, tephra and volcanic gas alone make living near the mountain genuinely risky. Since December 24th, 2024, Kilauea has been erupting on and off, mostly from 2 vents at the summit, one north, one south. These outbursts tend to come in short bursts, usually under half a day, followed by a lull. Is the volcano just taking it easy during these breaks? Not really. Sometimes those pauses stretch 2 weeks or longer, as if the lava is gathering its strength before the next round. Let's talk more about tephra, because its biggest danger is that it doesn't stay put near the crater. In previous eruptions, it's rained down on communities as far off as Hilo and Puna, clogging water systems and creating massive cleanup efforts. Hilo International Airport had to cancel every evening flight due to ash in the air, and for weeks afterward, both locals and park crews were sweeping tephra off rooftops, gutters, and streets everywhere. Park officials say the debris traveled so far because of a combination of weak winds and unusually tall lava fountains. When that happens, material simply drops straight down over the park and neighboring towns. In other eruptions, steady trade winds, which typically blow east to west across the islands, acted like a conveyor belt, hauling ash and gas over the Kau Desert and southwest toward nearby communities. There's another hazard tied to these eruptions worth mentioning: glass rain, sometimes called Pele's hair. It's a form of tephra that forms specifically when lava fountains shoot up at high speed. Tiny gas bubbles inside the molten rock burst and stretch it into thin, fragile threads, which the wind then scatters far and wide. It's lightweight, but sharp enough to scratch skin or irritate eyes and lungs. The name comes from Pele, the Hawaiian goddess associated with fire and volcanoes, since the material seems to be born directly out of eruptive activity. Strands of it were reported drifting around the volcano during the major 2018 eruption. Kilauea isn't the only concern in the area either. Its neighbor, Mauna Loa, got a fresh update from researchers on March 5th, 2026. It isn't erupting, but it's inflating as magma fills its enormous underground chambers. Think of it as the mountain taking a slow, deep breath. Except this breath comes with consequences. Over 100 earthquakes were recorded beneath its summit in just the past month. Should that worry you? Let's break it down. Mauna Loa is the largest active volcano on the planet, spanning half of Hawaii's Big Island. When it erupts, it can send massive, fast-moving rivers of lava sweeping across the landscape, like an unstoppable bulldozer made of molten rock. Eruptions typically start at the summit, then lava can travel outward toward the northeast rift zone, the southwest rift zone, or vents on the northwest flank. What makes it especially unpredictable is that these flows can appear anywhere from minutes to months after activity first begins. Since its earliest well-documented eruption in 1843, Mauna Loa has erupted 34 separate times, with gaps ranging from just months to multiple decades between events. Its most recent eruption happened in 2022. At the moment, it's quiet but clearly active. Small earthquakes beneath the mountain confirm magma is shifting underground. In February 2026 alone, scientists logged 116 quakes beneath the summit, most clustered under the Mokuāweoweo caldera, with some concentrated in the southern caldera as well. But don't let that number spook you. The month before actually saw 123 quakes, slightly more. These tremors are simply part of the volcano's normal cycle as it refills with magma following the 2022 eruption. GPS instruments confirm the summit is inflating, the ground steadily rising as the underground reservoir fills. Meanwhile, gas and temperature readings from the southwest rift zone remain at typical levels, showing no significant deviation from previous months. So while Mauna Loa is undeniably recharging, there's no immediate indication of an eruption on the horizon. Even so, it's a giant worth watching closely, one that could wake at any moment, and researchers are tracking every inch of ground movement. If Mauna Loa does erupt, the consequences could take several forms. Fast-flowing lava could sweep across land in its path. The volcano itself could trigger earthquakes, as filling magma pushes the mountain's flanks upward or sideways. It could also release volcanic gases that combine with air to form fog, a hazy smog that irritates breathing for anyone downwind. And occasionally, it might produce small explosions that throw ash into the sky, creating hazards for nearby air traffic. Now let's head somewhere completely different, underwater. In 2015, a volcano erupted and the seafloor above it dropped about 8 feet, like an elevator car, suddenly losing its cable. By that point, researchers had already wired the area with sensors, hoping that since this particular volcano erupted fairly regularly, they could actually forecast the next event. And in a way, they succeeded. They marked 2025 as the likely window and waited. Except nothing happened. Yet the seafloor is still swelling and shaking on a near-daily basis, and that has everyone paying close attention. Here's why. Axial Seamount sits roughly 300 miles off the coast of Oregon, submerged nearly a full mile down. Down there, you'd also find something you might not expect. Miles and miles of yellow cable. This happens to be one of the most closely monitored volcanoes on Earth. Through a massive effort called the Ocean Observatories Initiative, researchers wrapped the underwater mountain in 550 miles of fiber optic line. Despite the name, it's less of a traditional observatory and more of an enormous ongoing experiment. There's no dome down there where people live and work. Instead, those cables power an extensive sensor network that counts quakes, tracks the ground rising by fractions of an inch, and picks up the low rumble of magma. These instruments are sensitive enough to detect the moon's pull. As tides rise, the added weight of water presses on the volcano and sets off tiny tremors. Installing all of it required remote-controlled robots diving down to physically connect each sensor to the network. Imagine trying to plug in a cable in total darkness, except you're doing it 4,600 feet underwater, using a mechanical arm under pressure strong enough to crush a small truck. So why bother with all this effort? Most volcanoes are patient. Some erupt once, blanket half a continent in ash, then stay dormant for hundreds of millions of years. Spend a career studying volcanoes and you might never witness an actual eruption. But Axial sits directly on a boundary where two tectonic plates are pulling apart, constantly refilling its magma supply. It doesn't need centuries to recharge. It can erupt roughly once a decade. And it doesn't blow apart violently like Mount St. Helens. There's no dramatic explosion. Instead, the seafloor swells, splits open, and lava seeps out quietly, building new rock as it goes. When that floor finally cracks, it releases a towering cloud of superheated water called a megaplume, loaded with subsurface bacteria. It rises thousands of feet and resembles a blizzard of white particles swirling through the dark ocean. Each eruption essentially resets the surrounding ecosystem, forcing local marine life to rebuild from scratch. That mix, frequent and relatively gentle, makes Axial an ideal research subject, active enough to gather real data, predictable enough to build forecasting models around. By 2014, the observatory was fully operational, just in time to capture the 2015 eruption live. Sensors on the ocean floor recorded the ground swelling like a balloon as molten rock pooled underneath, rising several feet before the pressure finally cracked the surrounding rock. That set off thousands of small quakes in a single afternoon. Then miles-long fissures tore open and lava spilled out. As the magma drained away, the ground lost its support and eventually the crater floor caved in. Capturing that 2015 event let scientists establish a baseline, a picture of exactly what conditions look like right before an eruption. So when the crater floor began swelling again and quake counts started climbing, researchers predicted Axial was heading toward another eruption in 2025. And then, nothing. The signals matched the same pattern that preceded the last eruption, yet no eruption followed. It's like pumping a tire well past the point it should burst, and it simply doesn't. So what threw off the forecast? The likely explanation is that the volcano's timing shifted. The ground rose quickly back in 2015, but the pace this time appears slower. Magma may be filling the chamber at a reduced rate compared to a decade ago. It's also possible the surrounding rock has grown stronger, resisting cracking and forcing even more swelling before it finally gives. There's a third possibility too, a slow, quiet leak where tiny fractures release just enough pressure to delay the main event, leaving the volcano primed and ready but without quite enough of a trigger. Even with all this instrumentation, it's genuinely difficult to tell almost there, apart from about to happen. That uncertainty is why the forecast shifted from 2025 to somewhere in mid to late 2026. The volcano stayed active, but its buildup slowed, pushing the likely breaking point back roughly a year. So why does this make scientists nervous? When people hear volcanic eruption, they often picture a tsunami racing toward shore. Not here. You can leave the surfboard at home. This is happening deep in the ocean, where the surrounding water absorbs nearly all the released energy. The surface might bubble slightly, but nobody at the beach will even notice. The people actually sweating over this are the ones who funded all those robots and sensors. Here's the real issue. The lab itself is sitting inside the experiment. This volcano is already overcharged. It's swelled well past the point where it typically erupts. If it waits until late 2026 to finally release, it could be holding significantly more magma than it did back in 2015. A bigger eruption means richer scientific data, sure, but it also means a far larger volume of lava, and those pricey yellow cables and delicate instruments are sitting directly in its path. If the lava follows familiar routes, the equipment survives. But an overpressurized release could tear open entirely new cracks in the seafloor, and if that happens, researchers could lose millions of dollars in gear within seconds. Scientists could be watching the live feed, see a wall of molten glass approaching, and then nothing but static. But the real concern isn't the money. Axial is supposed to be the benchmark, the most closely monitored patch of ocean floor anywhere on the planet. This was meant to be the easy case. If the prediction model fails here, it's a troubling sign, because researchers have thrown every available sensor at this volcano and still don't fully understand how it behaves. If forecasting struggles even with the friendliest, most wired-up volcano on Earth, what does that mean for the ones we can't monitor nearly as closely? Vents around Axial pump out water reaching roughly 650 degrees Fahrenheit. On the surface, that would flash instantly into steam. Down there, the pressure is so extreme the water can't boil, but it's hot enough to dissolve minerals right out of the rock. It's loud too. If you could hear it directly, it would sound like a jet engine idling on a runway. The seafloor around the vents is also carpeted with tube worms, pale, 6-foot-tall creatures with vivid red tips that make almost no biological sense. They have no eyes, no mouth, and no stomach. Instead, they house bacteria inside their bodies that convert the volcano's toxic sulfur gas into usable sugar, essentially living off pollution. Crawling across them are scale worms, covered in microscopic plates that bend light, so a flashlight beam makes them shimmer in flashes of blue and red. Even the ground itself is strange. When Axial erupts, the lava hits freezing seawater and cools almost instantly. But instead of turning into ordinary gray rock, it hardens into pure black volcanic glass. Walking across it would supposedly sound like crunching through thousands of shattered light bulbs. Researchers have already updated this year's monitoring schedule. Cameras are positioned to capture the action, and there's even a chance of a live YouTube stream showing the seafloor tearing open in real time. Let's just hope it isn't the final broadcast those cameras ever send. It's tough to stream the next eruption once a multi-million-dollar camera has been swallowed by a river of molten glass. And that wraps up today's deep dive. If this satisfied your curiosity about the volcanoes quietly stirring around the world, drop a like and share it with someone who'd find it just as unsettling. Or if you want more, check out the videos on screen and stay curious.